Working in IT is more than just a job, it's a career path. Research shows that the field of IT support is a launchpad for future career growth and better wages. In fact, a study on the subject was recently conducted by the Harvard Business School, Accenture, and Burning Glass entitled Bridge the Gap. It found that among today's middle-skill jobs, which require training but not a formal college degree, IT support offers clear pathways to prosperity. We saw this phenomenon play out here at Google in our IT support program. Those who pushed themselves to learn how to code in Python typically saw strong career growth. They built skills that are critical to accessing higher-level positions in the IT field. And after honing those skills through hard work and determination, they advanced into more technical IT support specialists, systems administrators, technical solutions engineers, and even site reliability engineers. The common thread across all of these roles is knowing how to write code to solve problems and automate solutions. By expanding your toolbox to include coding skills, you open a window into the world of systems management that can lead you towards more advanced technical roles down the line. Python in particular is having a huge surge. According to the 2019 Stack Overflow Developer Survey, Python is the coding language most people want to learn, the second most loved by those who already know it, and the fourth most popular overall. So why take this program to learn how to code in Python? Well, first, it's geared towards people who are already in or aspiring to be in the field of IT. Maybe you're thinking bigger about your current IT role and want to work towards managing operations at scale. Or maybe you're just starting out and looking to break into the IT industry. Perhaps you've taken our IT Support Professional Certificate program on Coursera already. Or you have equivalent IT support knowledge with basic computing skills, like working with files and directories, familiarity with networking concepts, and understanding how to install software on your computer. In any case, this program is tailor-made for you. Second, this program offers 3 hands-on methods of teaching coding in Python and automation: Code Blocks, Jupyter Notebooks, and QuickLabs. And third, we've assembled an awesome group of Googlers who will serve as your instructors in each course. They all started their careers in IT support, then learned programming, and moved on to more technical roles, like me. We can't wait to share our stories with you and how we use Python in our day-to-day. Oh, and hey, I should probably introduce myself. My name is Christine Rafla, and I'm a systems administrator at Google. I will be your instructor in this course. This program has been entirely designed and developed by Google, and we even filmed each course at different cool Google spaces. It'll introduce you to the Python programming language with a special focus on how this language applies to automating tasks in the world of IT systems support and administration. I'm super excited to be here with you. When I was younger, I had no idea that careers in IT even existed. There are a lot of reasons I wanted to participate in this certificate program, but one of my biggest motivations is that I want to see more women represented in the industry. I remember going to a system administration summit where there were hundreds of men and about 3 women that were sysadmins. A lot has changed since then, but there's still so much we can do to bring new ideas and representation into the IT field. That's why I want to share my knowledge with as many people as possible. I love my job and I love the people I work with because they make it easy to ask for help and offer their guidance. This type of support network allows our team and ultimately our industry to be more successful. I understand from experience that it can feel pretty intimidating and maybe even a bit scary to learn a coding language. Just remember, everyone started where you are right now, with the first command, the first script, and of course the first of many errors. When I started out in my career, I strived to get everything perfectly right the first time I tried it, but that actually slowed down my progress. So don't be afraid to make mistakes. It will give you a leg up. So let's get down to it. What's ahead? The program begins with a crash course in Python where you will learn to write simple programs and understand their role in automation. Next, we'll get more hands-on focus on how Python interacts with the operating system. After that, we'll cover how to use Git and GitHub to manage versions of your code. Then, we will focus on troubleshooting and debugging techniques to find and solve the root cause of problems in IT infrastructure. The next course covers automating at scale, where you will learn to deploy configuration management on a fleet of either physical or virtual machines running in the cloud. And last up, we will bring all this knowledge together and complete a final project designed to solve tasks that you might encounter in real-world IT settings. Bonus, you can post your projects to GitHub to show off your fancy new skills to employers or friends, or both. Phew, that was a lot to rattle off. Are you excited or what? Now I'd like to quickly introduce you to my fellow instructors who you will get to meet along the way.
Hey, my name is Roger Martinez. I'm a Linux system administrator, and I'll be your instructor in the course on using Python to interact with the operating system.
Hi, I'm Kenny Suleiman, and I will be your guide in the course about using Git and GitHub to manage versions of your code.
Hi there, I'm Amanda Bellis, and I'll be teaching you about troubleshooting and debugging.
Hey, I'm Phelan Vendeville, and in my course we'll learn about automation at scale using configuration management and the cloud.
Thanks, everyone. This all-star team was brought together to guide you on your adventures in coding. You're in very good hands. Okay, I think that's everything. Let's get ready to learn some new skills and maybe even have some laughs along the way. I'll see you in the next video. If you work in IT, computer programming skills open up an incredible amount of opportunity. Being able to write scripts and programs that tell your computer to perform a task equips you with an invaluable tool. Not only does it make your work easier and more efficient, it can help you grow faster and advance further in your IT career. But how do you even start to learn a programming language like Python? How do you recognize when to tell a computer to perform a task? And how do you then write a program to actually get your computer to complete the task you want it to do? The thought of learning to write a program in Python can make you feel a whole bunch of emotions. Excitement, anticipation, that feeling of wanting to dive right in and get going. And also fear. You might ask yourself, can I really learn how to code, or do I have it in me? I'm here to tell you, yes, you can absolutely do this. Learning how to program can be scary and intimidating, but at the same time, it's really fun and really exciting. In coding, as in life, if we're gonna get philosophical, the most rewarding work is usually a bit challenging, but ultimately well worth the effort. Of course, I'm able to say all this from experience, especially the cheesy parts. My name is Christine Rafla. I'm a systems administrator at Google, and I'm going to be your instructor and guide in this course. The role of a sysadmin can vary a lot from company to company, and even within different teams in the same company. I happen to work in the Corporate Identity and Access Management Operations team, which is a really long way of saying that we make sure that everyone is represented correctly, and if they need to access certain resources, they can. What I love the most about being a sysadmin is that the role has so many diverse functions. We handle loads of unique problems and edge cases, from tinkering with different systems to collaborating with other teams. I am always learning something new, so it's really hard to get bored. It all starts with knowing how to automate. If you're an IT support specialist, a systems administrator, or in a role somewhere in between, knowing how to get computers to do the hard work for you will set you apart from others in similar IT roles and make your life much easier. Think about it. Would you rather manually deploy 100 computers on your own, or tell your computer to do it all for you, all at once? No brainer, right? Having a coding skill set can help you grow into more specialized roles, like a systems administrator, cloud solutions engineer, DevOps specialist, site reliability engineer, or who knows, maybe even web developer or data analyst. The point is, being able to write a program is an essential tool in your IT toolkit, and more employers are looking for these skills in the people they hire. If you've ever learned a new skill, like playing a musical instrument, speaking a foreign language, knitting, or skateboarding, you know that getting good at something new requires a lot of practice. For me, I love to learn new languages, and I'm proud to say I speak Spanish, Arabic, French, and I even know 10 words in Russian. Our world is shaped by the words and the languages we speak, and while some words may be unique to one language, you can always find similarities that help you learn and understand. Being able to connect the dots between cultures allows me to see things others might not. Kinda sounds like this applies to IT programming, huh? My point is, whether you're learning French or Python, it's never easy. You have to start small, learn the basics, and practice those until you master them. Only then can you move on to more complex and impressive stuff. And I'm here to help you along that path, along with my colleagues who you'll meet in later courses. We'll start slow, master the foundations together, and you'll soon be ready for more challenging stuff. So are you wondering why we filmed this course in a cabin on a lake in Canada? The truth is, we're actually in a game room at one of the Google offices in Sunnyvale, California. We chose a different themed office space for each course of the program just to mix things up, and I think I scored with this one. I should warn my manager that I'll be hanging out in this one well after the course ends because it's super comfy. By the end of this course, you'll understand the benefits of programming in IT roles. You'll be able to write simple programs using Python, figure out how the building blocks of programming fit together, and combine all this knowledge to solve a complex programming problem. That's right, by the end of this course, you're going to write a program in Python that's designed to solve a real-world IT problem. Super exciting, right? We'll start off by diving into the basics of writing a computer program. You'll get hands-on experience with programming concepts through interactive exercises and real-world examples. You'll quickly start to see how computers can perform a multitude of tasks. You just have to write code that tells them what to do. Along the way, we'll be talking about automation, which is the process of getting computers to automatically do a task that us humans normally have to do by hand. Now, some of this stuff can get a little complex and confusing. I promise to do my best to make these lessons clear and easy to understand. But if you get stuck at any point, please feel free to rewatch the videos. Practice as much as you like and take the time you really need to understand these topics. The goal of this course isn't to teach you everything there is to know about software engineering because, yikes, that would be a long course. Instead, we're going to introduce you to some of the key concepts of programming and scripting that will empower you to spot opportunities for automation in real life. You're about to learn a skill that can help you take your career to whole new levels. Are you excited? I'm excited. So let's jump in. As the Chinese proverb says, a journey of 1,000 miles begins with a single step. Today's a big day. You're taking your first step in your journey to learn how to write scripts in Python. It's going to be a little challenging at times, but really it's not that scary. We'll go slow and give you everything you need to fully grasp each concept before we move along. In the next few videos, we'll discover the fundamental concepts of computer programming. You'll learn what a programming language is, what scripting is, what languages are out there other than Python, and how this all relates to IT. We'll also have you coding before you know it with small coding exercises we've cooked up to give you hands-on practice with Python. This will include writing your very first Python script. But always keep in mind, if at any point along the way you feel lost or confused, don't panic. You can watch the videos as many times as you need to let the concepts sink in. Plus, you can ask questions in the discussion forums, which is one of the best ways to find extra information and connect with other learners. When I was asked to participate in this program, it made me think about when I first started to code. If I could give that younger version of myself a piece of advice, this is what I would tell her. It never works the first time. Seriously, as a newbie, I expected it all to work like magic. I thought that following the rules and getting it right the first time would prove my value as a coder, but that's just not true. Not even the best of the best. If you expect to write perfect code on the first shot, you're going to be disappointed. You hear that, younger self? Try not to feel overwhelmed by the details. Connecting the dots only comes with experience, so best way to learn is to just jump in. The truth is, everyone learns at their own pace. If you already know some of these concepts, feel free to skip ahead to the parts that interest you the most. If you're starting from scratch, take as long as you need for each concept. The assessments will be right there waiting for you when you're done. And if at any point you start doubting yourself, remember, even the most advanced programmers started thinking, Python? What's Python? Well, we're about to learn all about it, so let's dive in. Next up, we'll be doing a rundown of what programming is. At a basic level, a computer program is a recipe of instructions that tells your computer what to do. When you write a program, you create a step-by-step recipe of what needs to be done to complete a task. And when your computer executes the program, it reads what you wrote and follows your instructions to the letter. How nice is that? The recipe is written in a code called programming language. Programming languages are actually similar to human spoken languages since they have a syntax and semantics. Now, if it's been a while since your last grammar class, here's a quick refresher on syntax and semantics. In a human language, syntax is the rules for how a sentence is constructed, while semantics refers to the actual meaning of the statements. In English, sentences generally have both a subject, that's a person, place, or thing, and a predicate, usually a verb, and a statement that explains what the subject is doing. Let's take the sentence, Paula loves to program in Python, as an example. In this sentence, Paula is the subject, and loves to program in Python is the predicate. To form a sentence that others can understand, you need to know both the syntax that constructs the sentence and the semantics that gives it meaning. The same applies to programming languages. In a programming language like Python, the syntax is the rules for how each instruction is written, and the semantics is the effects the instructions have. Much like spoken languages, there are lots of programming languages to choose from. Each has its own history, features, and applications, but they all share the same fundamental ideas. So once you understand the basic concepts in one programming language, it becomes much easier to learn another. And lastly, computers always do exactly what they're told. So when you write a program, it's important to be super clear about what you want the computer to do. Learning the syntax and semantics of the programming language you choose will allow you to do just that. Make sense? Before we continue, let's spend a moment on terminology. In the next few videos, you'll hear the term script being used a bunch. So what's the difference between a script and a program? The line between the two can be a bit blurry, and in this course, we'll use the terms interchangeably. In general, you can think of scripts as programs with a short development cycle that can be created and deployed rapidly. In other words, a script is a program that is short, simple, and can be written very quickly. In this course, we'll focus on a specific scripting language called Python, which we'll use to learn the basics of programming. We'll learn about the Python syntax, the rules of how to write a Python program, and the semantics, or meaning, of the different pieces involved. Before we start learning how to code and having you write your first Python script, let's talk more about what automation is and why it's useful. Although we might not realize it, we reap the benefits of automation all the time in our daily lives. Do you ever pay your bills with scheduled payments or use a self-checkout at the grocery store? I always set my coffee machine to start brewing before I've even gotten out of bed. The promise of fresh coffee makes early mornings way easier. Automation is the process of replacing a manual step with one that happens automatically. Take a traffic light, for example, which continuously regulates the flow of vehicles at an intersection. A traffic light requires a human intervention only when it needs repairs or maintenance. The automatic regulation of traffic means that humans don't have to stand at the intersection manually signaling when cars should stop or go. Instead, people can concentrate on more complex, creative, or difficult tasks like focusing on where you're driving. What's more, traffic lights don't get tired, bored, or accidentally display a green light when they met red. This highlights another benefit of automation: consistency. Let's face it, us humans are flawed and sometimes we make mistakes. A human performing the same task hundreds of times will never be as consistent as a machine doing the same thing. But for all of its advantages, automation isn't a solution for every situation. Some tasks just aren't suited for automation. For example, they may require a degree of creativity or flexibility that automatic systems can't provide. Or, for more complicated or less frequently executed tasks, creating the automation may actually be more effort or cost than it's worth. Think about when you get a haircut. What would it take to automate the actions of cutting hair with a machine? The client's height, the shape of their head, their current hair length, and desired hairstyle would all need to be taken into account when designing the automatic system. We'd need to replicate the creativity and skills of a trained specialist, along with extensive testing to ensure the client's safety and quality haircut. And if you've ever had a bad experience at a hair salon, you know quality can be subjective. In this case, the cost and effort of automation just isn't worth the benefits of an automatic haircut would provide, which is why we don't have robot hairstylists. Not too complex, right? Automation is a powerful tool when used in the right place at the right moment. It can save time, reduce errors, increase consistency, and provide a way to centralize solutions and mistakes, making them easier to fix. Throughout this course, and in upcoming ones, we'll be talking about when it makes sense to apply automation and exactly how you do it. Eventually, knowing when and where to use automation will become automatic for you. Working in IT, a lot of what we do boils down to using a computer to perform a certain task. In your job, you might create user accounts, configure the network, install software, back up existing data, or execute a whole range of other computer-based tasks from day to day. Back in my first IT job, I realized that every day I came into work, I typed the same 3 commands to authenticate into systems. Those credentials timed out every day by design for security reasons. So I created a script that would automatically run these commands for me every morning to avoid having to type them myself. Funny enough, the team that monitors anomalous activity discovered my little invention and contacted me to remove it. Oops. Tasks performed by a computer that need to be done multiple times with little variation are really well suited for automation. Because when you automate a task, you avoid the possibility of human errors and reduce the time it takes to do it. Imagine this scenario. Your company had a booth at a recent conference and has gathered a huge list of emails from people interested in learning more about your products. You want to send these people your monthly email newsletter, but some of the people on the list are already subscribed to receive it. So how do you make sure everyone receives your newsletter without accidentally sending it to the same person twice? Well, you could manually check each email address one by one to make sure you only add new ones to the list. Sounds boring and inefficient, right? It could be, and it's also more error-prone. You might accidentally miss new emails or add emails that were already there. Or it might get so boring you fall asleep at your desk. Even your automated coffee machine won't help you out there. So what could you do instead? You could get the computer to do the work for you. You could write a program that checks for duplicates and then adds each new email to the list. Your computer will do exactly as it's told, no matter how many emails there are in the list. So it won't get tired or make any mistakes. Even better, once you've written the program, you can use the same code in the future situations, saving you even more time. Pretty cool, right? It gets better. Think about when you're going to send these emails out. If you send them out manually, you'll have to send the same email to everybody. Personalizing the emails would be way too much manual work. If instead you use automation to send them, you could have the name and company of each person added to the email automatically. The result? More effective emails without you spending hours inserting names into the text. Automating tasks allows you to focus on projects that are a better use of your time, letting computers do the boring stuff for you. Learning how to program is the first step to being able to do this. If you want to get computers to do the work for you, you're in the right place. Earlier in this video, I told you about the first task I ever automated. Now I want to tell you about the coolest thing I ever automated. It was a script that changed a bunch of access permissions for a whole lot of Google internal services. The script traversed a large directory tree with tons of different files, checked the file contents, and then updated the permissions to the services based on the conditions that I laid out in the script. Okay, I admit I'm a total nerd, but I still think it's really cool. Next up, it's time to share your ideas. What things would you like to automate using programming? While these discussion prompts are optional, they're really fun. Seriously, they let you get to know your fellow learners a bit and collaborate on ideas and insights. Make sure you read what others are saying. They may give you ideas that you haven't even thought of. After that, you're ready to take your very first quiz of the course. Don't worry, it's just for practice. Welcome back. How'd you do on your first quiz? If you got most of the questions right, great job. If not, no worries. It's all part of learning. We'll be here to help you check that you've really got your head around these concepts with regular quizzes like this. If you ever find a question tricky, go back and review the videos and then try the quiz again. You want to feel super comfortable with what you've learned before jumping into the next lesson. Remember, take your time. I'll be here whenever you're ready to move on. Okay, feeling good? Great, let's dive in. In this course, we'll use the Python programming language to demonstrate basic programming concepts and how to apply them to writing scripts. We mentioned that there are a bunch of programming languages out there. So why pick Python? Well, we chose Python for a few reasons. First off, programming in Python usually feels similar to using a human language. This is because Python makes it easy to express what we want to do with syntax that's easy to read and write. Check out this example. There's a lot to unpack here, so don't worry if you don't understand it right away. We'll get into the nitty-gritty details later in the course. But even if you've never seen a line of code before, you might be able to guess what this code does. It defines a list with names of friends and then creates a greeting for each name in the list. Now it's your turn to make friends with Python. Try it out and see what happens. Throughout this course, you'll execute Python code using your web browser. We'll start with some small coding exercises using code blocks, just like the one you experimented with. Later on, as you develop your skills, you'll work on larger, more complex coding exercises using other tools. Getting good at something takes a whole lot of practice, and programming in Python is no different. We recommend that you practice every example we share in this course on your own. If you don't have Python installed on your machine, no worries. You can still practice using an online Python interpreter. Check out the next reading for links to the most popular Python interpreters available online. Now, I'm sure you're wondering, what the heck is a Python interpreter? In programming, an interpreter is the program that reads and executes code. Remember how we said a computer program is like a recipe with step-by-step instructions? Well, if your recipe is written in Python, the Python interpreter is the program that reads what's in the recipe and translates it into instructions for your computer to follow. Eventually, you'll want to install Python on your computer so you can run it locally and experiment with it as much as you like. We'll guide you through how to install Python in the upcoming course, but you don't have to have it installed to get your first taste of Python. You can practice with the quizzes we provide and with the online interpreters and code pads that we'll give you links to in the next reading. We'll provide a whole bunch of exercises for you, but feel free to come up with your own and share them in the discussion forums. Feel free to get creative. This is your chance to show off your new skills. Remember how we mentioned that Python is simple and easy to use? Python makes it easy to express the fundamental concepts of programming, like data structures and algorithms, with easy-to-read syntax. This makes Python a great language to use to learn programming. And there are other reasons to pick Python too. Python is super popular in the IT industry, making it one of the most common programming languages used today. Python isn't new. Its first version was released by Guido van Rossum back in 1991. Since then, the community that develops it has grown and the language has advanced a lot. Whenever there's a significant change to the semantics or syntax of the language, a new major version is released. In 2000, Python 2 was released. In 2008, we got Python 3. In this course, we'll use Python 3.7, which came out in 2018. For many years, Python was considered a beginner's language and was mostly used for teaching concepts or writing very small, simple scripts, like in this course. But in recent years, the adoption of Python has grown dramatically. One reason for this is that the language has become more powerful. It's also because there's more tools available in Python for a growing range of applications. You can use Python to calculate statistics, run your e-commerce site, process images, interact with web services, and do a whole host of other tasks. Python is perfect for automation. It lets you automate everyday tasks by writing simple scripts that are easy to understand and easy to maintain. That's why Python is the language of choice for lots of people working in IT support, system administration, and web development. Not only that, but it's also used in fast-growing areas of IT like machine learning or data analytics. Last but not least, Python is available for download on a wide variety of operating systems like Windows, Linux, and macOS. And what's more, Python is so popular in the workplace that if you are currently working in IT, you've most likely encountered it already. And if you're planning a career in IT, chances are you'll interact with Python quite a bit. So, there's a whole lot of reasons for why Python is relevant to today's IT industry. A large part of programming is learning through trial and error and asking questions. So if at any point you get stuck, don't get discouraged. Making mistakes helps you improve. The more you see failure or broken code as an opportunity to learn, the quicker you'll master programming. I remember the first Python script I ever wrote. It took a lot of refactoring, debugging, and testing to get it to work. I relied on a lot of my teammates for help and mentorship and wound up spending more time on Stack Overflow than actually writing the code. Thankfully, you don't have to reinvent the wheel. There's almost always someone on the internet who's tried to do what you're doing and can help point you in the right direction when you're stuck. Sometimes it takes a village. It's really important to keep in mind that even experienced programmers may need to ask a colleague a question from time to time, or look something up on the internet. Whether you're a programming novice or have some experience in software development, remember, the best programmers overcome challenges by seeking help or using other resources. Once you've completed this program, you'll be well on your way to confidently programming in basic Python. There's lots of information online that will help you continue to develop your programming skills. For example, there are lots of online courses for specific programming languages. You'll find answers to your Python coding questions in the official Python documentation. You can use sites like Stack Overflow to discuss and share with other developers, and you can ask questions in our discussion forums. You can even subscribe to some of the Python mailing lists to keep in the know on the latest updates to the language. You're opening the door to the whole world of programming, and it's super exciting to be joining the development community. The most important thing to remember is that you're never alone. Any questions you may have, any time in your career, there are resources out there to help you find the answers you need. Wow, that was a lot of information. Feel free to take a quick break, grab something to drink, and then head on over to the supplemental reading to learn more about Python and the resources out there to help you learn. Although we picked Python for this course, it's important to note that it's just one of the many coding languages out there. Think of a given programming language as just one of the many powerful tools in your IT toolbox. Each language has its unique set of pros and cons. Some run faster than others, some are better suited for enterprise applications, others are particularly good at crunching numbers. There are platform-specific scripting languages like PowerShell, which is used on Windows, and Bash, which is used on Linux. Both are widely used by system administrators on those platforms. There are also general-purpose scripting languages similar to Python, like Perl or Ruby, which are also widely used for scripting and automation. JavaScript, which was originally developed as a client-side scripting language for the web, is increasingly used as server-side for a broader set of tasks. And the list doesn't stop there. There's a vast array of traditional languages to explore, like C, C++, Java, or Go. As you progress in your career in IT, you'll probably encounter a number of different languages and learn when to use each of them. But let's not get ahead of ourselves. First, we have Python to get our heads around. A nice feature of learning the basics of programming in one language is that you can generally apply the same concepts you learn to other languages. This means that once you're familiar with Python, you'll find it easier to pick up new coding languages, as you'll spot and understand similarities and differences between them. After all, every language needs to do some common things like create variables, control the flow of a program, read input, and display output, even if they do these tasks using different approaches. As we called out earlier, learning a programming language is somewhat similar to learning a foreign language. You'll need to grasp the syntax and semantics for that language. Luckily for us, once you know the fundamentals of programming, learning another language is much easier than learning a second foreign language. There are a lot more similarities between programming languages than differences. To explore some of the similarities and differences between various scripting languages, let's take a look at a simple program that prints the words "Hello World" 10 times in 3 different languages: Python, Bash, and PowerShell. As you can see, each language uses a different approach to printing "Hello World." But look closer and you'll see similarities too. Each language must somehow put text onto the screen. The command for Python is print. For Bash, it's echo, and for PowerShell, it's write host. Also notice that each language has to count to 10 in some way. While Python does this by specifying range 10, Bash uses a sequence notation to count from 1 to 10. PowerShell has the most complex syntax in this example, but it also boils down to starting at 1 and counting up to 10. So, as we've just seen, there's a whole lot of programming languages out there. But don't let that scare you. In this course, you will only need to focus on learning Python. Once you can speak Python, you can go on to learn any other language you want. Up next, we've got another quiz to help you practice what you've just learned. Now that you've got an idea of what Python code looks like, let's check out one of the most basic examples and dive deeper into what's going on. Get ready. We're going to use a Python interpreter to make our computers say hello to the world. When we run this code, either locally on our machine or on a web interpreter, the words "Hello World" appear on the screen, just like magic. Actually, it's not magic. It's because print is a Python function that writes what we tell it to on the screen. Like the statement "Hello World," for example. The print function is part of the basic Python language. Whenever we use keywords or functions that are part of the language, we're using the programming language's syntax to tell the computer what to do. So, what are functions and keywords? Functions are pieces of code that perform a unit of work. We'll talk a lot more about functions later on, and you'll even learn how to write your own. Keywords are reserved words that are used to construct instructions. These words are the core part of the language and can only be used in specific ways. Some examples include if, while, and for. We'll explain all of those and a bunch more later in the course. As we called out, the keywords and functions used in Python are what makes up the syntax of the language. Once we understand how they work, we can use them to construct more complex expressions that get the computer to do what we want it to do. Last off, notice how hello world is written between double quotation marks. Wrapping text in quotation marks indicates that the text is considered a string, which means it's text that will be manipulated by our script. In programming, any text that isn't inside quotation marks is considered part of the code. Now for a bit of trivia. Do you know why we greeted the whole world in our example? Well, printing hello world has been the traditional way to start learning a programming language since way back in the 70s, when it was used as the first example in a famous programming book called the C Programming Language. That example looked like this. In Python, the hello world example is just one line. In C, it's 3 lines. In other languages, it could be even more. While learning to write hello world won't teach you the whole language, it gives you a first impression of how functions are used and how a program written in that language looks. Alright, now that we've written our first piece of Python code, I think you're ready for something a bit more challenging than hello world. Ready? Let's do it. On the whole, for a program to be useful, it needs to get at least some information from the user. With this data, the program can take actions that are relevant to the user, instead of generic actions like printing hello world. Data can be provided to a computer in a bunch of different ways. For example, on a website, you might input data by entering text into text fields or clicking links. If you're using a mobile application, maybe you'll click on buttons or select preferences from a drop-down menu. In a command line program, you might provide additional data by passing strings as parameters to the program, or you could have the program ask you for data interactively. All these various platforms, programs, and apps process data differently. Some might take the contents of a file as data to be processed, others gather data from other sources and process it in the background. Remember our earlier example when we automated the process of identifying and removing duplicate emails? There, the data provided to the program was the list of emails, which would usually be given in a file that lists the emails one per line. Whichever way your application gets the data, it will need to come from somewhere. For our first examples in this course, we'll just have the data as its own line in our block of code. This is limited, but straightforward. Later in this course, and in upcoming courses, we'll introduce you to better ways of feeding data into your code. For now, though, let's see this idea in action in a very simple example. By having the name separate from the call to the print function, we're making the line of code that calls the print function generic, while still personalizing the greeting. If we then wanted to say hello to a different person, we only need to change the name, but the call to the print function will remain the same. Pretty simple, right? Next up, we'll learn a few other easy things that you can get Python to do for you. There's a ton of things that you could do with Python, and you'll learn many of them in this course. But before we dive into complex subjects, let's have some fun with another simple task that you could do with Python. We're going to make Python our calculator. And let's start with something easy. So, 4 plus 5 is 9. 9 times 7 is 63. Minus 1 divided by 4 is minus 0.25. Easy. Repeating or periodic numbers are printed in a longer format. Let's try 1 divided by 3. In math theory, when 1 is divided by 3, the digit 3 repeats forever after the decimal point. Of course, it's hard to display something that repeats forever, so instead we have a representation showing lots of decimal places. Not too hard, right? Let's give the computer something a bit trickier. Let's say we want to divide 2050 by 5, then subtract 32, and then divide the result by 9. To do this, we'll need to use parentheses, just as we do in typical math problems. You can also use Python to get squares, cubes, or any power of n of a number. For example, let's say we want to find out what 2 to the power of 10 is. To get Python to give us the answer, we use the double star operator. If you're starting to worry that this is becoming an algebra course, relax, we're not going to do anything more complex than what we've just seen. And if you're thinking, why would I use Python instead of just a normal calculator? That's a valid question. Experimenting in this way, you get familiar with the language's math capabilities. And in IT jobs, there are many tasks that require you to use math calculations. You might need to count how many times a certain word appears in a text, or work out the average time it takes for an operation to complete, or how much you have to compress an image to fit in certain size constraints. Whatever you need to calculate, writing a script can help you do it faster and with more accuracy. So you need to know what mathematical operations are available to you. Python actually has a lot more advanced numeric capabilities that are used for data analysis, statistics, machine learning, and other scientific applications. We won't get into these in this course, but if you want to learn more about them on your own, there's a wealth of online resources available. Next up, a cheat sheet to help you with programming concepts that we've just covered. And after that, it's time for another quiz. This time with a few small coding exercises. Remember, if something isn't clear, you can re-watch the videos as many times as you need. Ready? You've got this. Congrats! You made it to the end of the first module. Great job! You've taken the first steps to learning a new programming language and growing your IT skill set. Getting there shows real determination and a will to learn. We've covered a lot of topics, and many might be new to you if you've never learned about programming before. You've discovered what scripting is, what the syntax and semantics of a programming language are all about, and how they relate to automation. We've got to grips with small blocks of Python code, talked about why Python is relevant to IT, and explored what other programming languages are available. We've had our first approach to how to input data and write a script that puts this data to use. And we've seen how you can use Python to perform typical math calculations. Not bad for your first Python steps, right? This is just the beginning of an exciting journey learning to code, and we hope you're eager to learn more. Coming up, get ready for your first graded assessment. These assessments help you check whether you've understood all the concepts and that you're ready to move on to the next stage. Now, don't worry, if at any point you're not sure about a question, you can always review the videos and readings to remind yourself of the answer. Remember that everybody learns at different speeds, so take your time, really get familiar with the concepts. And once you feel ready, the assessment is there waiting for you. I'll see you back here once you've nailed it.
My name is Margarita Manterola. I'm a site reliability engineer in the G-Linux team. I'm very passionate about teaching programming to everybody. I think it's very important that everybody can learn how to tell the computer what to do. One of the things that really inspired me about the first program was that it was targeted to people that were not from a computer science background. As I myself don't come from a computer science background, I felt really identified with that. And I wanted to help all these people keep growing and keep learning and keep getting more and more skills. So that's why I want this program to be successful as well. I got involved in developing this program early on because I was really excited about being able to reach thousands of learners and being able to help all these people grow their skills. Working together with people is really important. For this program, I collaborated with a ton of different people, from people inside Google, outside Google. I got reviews from people, I got new ideas, and I think it's really important because it made the scripts better. The reviewers suggested new things that should be added or pointed things that didn't make sense, and I kept incorporating the ideas into the scripts so that the content delivered was the best possible. And if it had been just me, that wouldn't have been possible. It's really important to incorporate many different points of view. It's been a lot of work, but I really enjoyed it. I enjoyed the process, and it's really exciting to get it to come to life. So I hope this program helps people keep growing and keep expanding their horizons so that they can reach their full potential.
Hi there, welcome back. And well done for completing your first graded assessment. You're doing a great job making it this far. Chances are, some topics we've covered may have been a little tricky at times, especially if you're completely new to programming. Don't worry if something wasn't obvious right away. We went through a lot of new concepts and it might take several passes until you feel comfortable with them. And that's totally normal. We all went through it when we were learning how to code. In the previous module, we explored some basic concepts like programming and automation. We called out that each programming language has a specific syntax, which we need to learn so we can tell the computer what to do. We then got a sneak preview of some of the things we could do with Python. Up next, we'll dive deeper into some basic building blocks of Python syntax. Things like variables, expressions, functions, and conditional blocks. At first glance, these pieces may seem pretty simple, but when we start to combine them, they become a lot more powerful. Understanding a programming language's syntax isn't too different from learning a spoken language. For example, the best way to learn Spanish is to visit a Spanish-speaking country. Immerse yourself in the culture, listen to the people, then figure out how to arrange the words to form a sentence that another speaker can understand. The same is true for programming. When you immerse yourself in Python programming, you'll learn how to formulate statements of code that the computer can understand. This is called syntax. Okay, so as you go through the next few videos, keep in mind that our main goal is to learn the language's syntax. So we'll focus on how to tell our computer what to do, not on how to get it to do complicated tasks. Like before, we'll run through some simple exercises to help you see the concepts in action. And as you pick up the new skills and get to grips with different tools, we'll start to write more advanced scripts that tackle more challenging problems. Again, if at any point you feel confused or that something just isn't clear, remember, you can watch the videos and take the practice quizzes as many times as you need. The key to getting good at programming is practice. Practice and practice. You have to keep working your programming muscles in order to get strong, just like building muscles in the gym. Train hard, train regularly, and you'll be tackling more weighty coding problems in no time. All right, ready to jump back in? In the next video, we're going to learn all about data types. Let's get started. In earlier videos, we called out that text written between quotes in Python is called a string. In programming terminology, a string is known as a data type. Whether it's a mobile game or a script used to automatically create user accounts, most programs need to manipulate some kind of data. And that data can come in a lot of different forms, or, like we call them, data types. A string is only one kind of data type found in Python. There's a bunch of others, like an integer, which represents whole numbers without a fraction, like 1. And float, which represents real numbers, or in other words, a number with a fractional part, like 2.5. Generally, your computer doesn't know how to mix different data types. For example, adding two integers together makes perfect sense to computers, like this. Adding together two strings also makes sense. We just end up with a longer string that contains the two, like so. But your computer doesn't know how to add an integer and a string. If you tell it to mix these two different data types, your computer isn't going to know what to do and will raise an error. Check it out. Oh no, our first error! But don't panic. Errors are a common part of programming, and you'll probably have to deal with them a lot. The trick is to think of errors as little clues from your computer to help you improve your programming skills. Read the errors carefully, understand what they're telling you, and then use that new knowledge to help you fix the mistake. In this example, the last line of the error message shows us that we've encountered something called a type error. When we get a bit of explanatory text that tells us that the plus sign can't be used between an int type and an str type, which are short names for integer and string, thinking about what we've already learned about strings, integers, and mixing data types, can you guess what the error is trying to tell us? The message unsupported operand type tells us that we can't add the integer 7 and the string 8 because they're different data types. But what if you didn't have an instructor to helpfully point that out? How would you know? You'd need to use your research skills and the resources we called out earlier in the course to do some investigating. For example, you could look for information about the error by pasting the type error message into the search bar of your favorite search engine. This is a common trick used by almost everyone learning to code, and even by experienced developers. You'll usually find that other people on the internet have reported similar errors and solved them too. Back to our example. Maybe you're thinking, aren't we adding two numbers here? Looks a bit like it, right? Well, look carefully and remember that anything wrapped in quotation marks is considered a string in Python. So 8 is a string here, while 7 is an integer. To the computer, adding 7 plus 8 is just as strange as adding 7 plus a is to us. And 7 plus a equals no sense at all. It might be helpful to think about data types in terms of information they can represent. For example, the name of a file would be represented as a string data type, while the size of that file might be an integer data type. If you're ever not 100% sure what data type a certain value is, Python gives you a handy way to find out. You can use the type function to have the computer tell you the type. This might come in handy when dealing with code that someone else wrote and you're not sure what data type it's using. For example, pretty neat, right? This tells us that A belongs to str class, which, like we said earlier, is short for string. The number 2 belongs to the int class, which is short for integer, and 2.5 belongs to the float class. We'll talk more about what we mean by class later in the course. For now, you can just use it as a synonym for data type. So now you know 3 very common data types in Python. There are plenty of others you'll be using soon, but don't worry about them at the moment. As we continue through the course, we'll come across more data types and learn how to interact with each of them. For now, just remember, mixing your data types will get your computer, well, all mixed up. So keep your strings with your strings, your integers with your integers, and your floats with your floats. And you shouldn't get in too much of a tangle. When we ask a computer to perform an operation for us, we usually need to store values and give them names so that we can refer to them later. This is where variables come in handy. Variables are names that we give to certain values in our programs. Those values can be of any data type, numbers, strings, or even the result of operations. We already used variables in some of our initial examples, like using them to store a name or a value. Now we're going to learn exactly how they work and how to make the most of them. Think of variables as containers for data. When you create a variable in your code, your computer reserves a chunk of its own memory to store that value. This lets the computer access the variable later to read or modify the value. Let's see this in action. Imagine a simple script that calculates the area of a rectangle using the formula area equals length times width. Area, length, and width can all be represented by variables, like this. In this script, we're creating 3 variables and storing different values in each. The process of storing a value inside a variable is called assignment. Here, we assign the length variable the value of 10. We assign the width variable the value of 2, and we assign the area variable with the result of the expression length times width. An expression is a combination of numbers, symbols, or other variables that produce a result when evaluated. In this example, we're multiplying the value of 2 variables to arrive at the value that we want. Finally, we use our old friend the print function to display the value of the area on the screen. Alright, we've just seen how to assign values to variables, use expressions to calculate more complex values, and then print the contents of a variable. Variables are important in programming because they let you perform operations on data that may change. For example, if we extended our rectangle script to accept any input as the value of the length and width variables, we could calculate the area of a rectangle of any size. Or to give a more IT-focused example, say we have a script that performs a specific operation on a file. We could extend that script to perform the same operation on any file, but only if the program used a variable to store the file name. You might have noticed that we assign a value to a variable by using the equals sign, in the form of variable equals value. Generally, you can name variables whatever you like, but there are some restrictions. First, you shouldn't use as variable names any of the keywords or functions that Python reserves for its own, like print. Using these reserved terms will make your program confusing to read and will result in errors. Python also has some restrictions on the characters you can use to define a variable. Variable names can't have any spaces, and they must start with either a letter or an underscore. Also, They can only be made up of letters, numbers, and underscores. Let's check out some examples of valid and invalid variable names to understand this better. I underscore am underscore a underscore variable is a valid variable name. I underscore am underscore a underscore variable 2 is also a valid variable name. 1 underscore is underscore a underscore number is invalid because variable names must start with a letter or underscore. Apples underscore and underscore oranges is invalid because it uses the special character ampersand. Last thing, remember that precision is important when programming. Python variables are case sensitive, so capitalization matters. Lowercase name, uppercase name, and all caps name are all valid and different variable names. And that rule on variables is invariable. In an earlier video, we saw how we can't use the plus operator between an integer and a string because they're different data types. But what happens when we try to operate with an integer and a float instead? Let's find out. Woohoo! Error-free! Python has no problem performing this operation. But what's up with that? Aren't integer and a float two different data types? They sure are, but there's a lot happening under the hood here. Behind the scenes, the computer is busy automatically converting our integer 7 into a float 7. This lets Python then add together the values to return a result that is also a float. We call this process implicit conversion. The interpreter automatically converts one data type into another. We've called this out before, but it's worth highlighting again that Python operations aren't just restricted to numbers. You can also use the plus operator to add together strings. This lets you do things like create sentences from individual words. Just don't forget to add spaces to each word, otherwise the computer will run them all together. So, what if you really want to combine a string and a number? Is it possible? It sure is, but only with an explicit conversion. In Python, to convert between one data type and another, we call a function with the name of the type we're converting to. Let's see how this works. Now things are getting a little bit more complex. Let's take a moment to unpack this to make sure it all makes sense. In this script, we're first calculating the area of a triangle, and when printing it, we're adding it to a string. To do this, we need to call the str function to convert a number into a string. Let's execute it and check out what happens. Our number got converted to a string and printed together with the message. Woohoo! We've learned a little bit about variables, values, expressions, and conversions. Next up, we've got a practice quiz to help you solidify your knowledge. As always, take your time and review the content if you need. You've totally got this. I'll see you in the next video once you're finished. Woohoo! You made it through another quiz! You are doing awesomely. Keep it up. So far, we've been looking at variables, expressions, and operations, which are the smallest components of scripts. Up next, we're going to look at functions, which are another crucial programming building block. We've come across a few Python functions in our example so far. The print function that writes text on the screen, the type function which tells us the type of a certain value, and the str function which converts a number into a string. All those functions come as a part of the language. And we'll look into a bunch of other built-in Python functions throughout this course. But now, we're going to see how to define our own functions to tell the computer to do things that the language's built-in functions don't. Let's start with a simple example. In this piece of code, we're defining a function. Our function takes a parameter. Here, that parameter is name, and prints a greeting for that name. This snippet is small, but it already shows a lot of important points about how we define functions in Python. Let's go through this step by step. To define a function, we use the def keyword. The name of the function is what comes after the keyword. In this example, the function's name is greeting. So to call the function later in the script, we'll use the word greeting. After the name, we have the parameters of the function, which are written between parentheses. In this example, we only have one parameter, name, followed by a colon at the end of the line. After the colon, we have the body of the function. That's where we state what we want our function to do. Note how the body is indented to the right. This is a key characteristic of Python, and we'll come across it a bunch. For now, just keep in mind that the body of the function must be to the right of the definition. In this example, the body contains just one line that calls the print function. Looks simple, right? But creating functions can actually be super powerful. The body of a function can have as many lines as we want it to, and do all sorts of fun stuff. We'll find out exactly what in later videos. But for now, let's execute our function and see what happens. That's nice, but it's not too interesting yet. Let's make it do a little more. Our function now receives 2 parameters instead of 1, name and department, and it writes 2 separate messages. Again, notice the indentation. We can add as many lines as we'd like to the body of the function, but each line must be indented the same number of spaces to the right. In this example, we're using 4 spaces. We could use 2 or 8 or any other number as long as they're all consistent. Let's try calling our new and improved greeting function. Nice. That's more useful. And we're only just scratching the surface of what we can do with functions. Remember that these are just simple examples, but a function can do a lot more than just print messages. In this course, and throughout the upcoming courses, we'll explore a bunch of other tasks that we can do with Python, and usually we'll write them inside functions. How are you feeling so far? These new concepts are coming fast and furious now. Are you starting to get to grips with it all? If so, awesome. And if some things are still a little fuzzy, now is a great moment to go back and review everything we've covered up till now. Once you're feeling good, meet me on over in the next video. We've seen how we can pass values into a function as parameters by passing values like the name or department in the example earlier. But what about getting values out of a function? This is where the concept of return values comes to play. The work that functions do can produce new results. Sure, we can print the results on the screen, but what if we wanted to use those results later in our script, or didn't want to print them at all? We can do this by returning values from the functions we define ourselves. Let's go back to calculating the area of a triangle. Do you remember our triangle example from our earlier exercise? The area of the triangle is calculated as base times height divided by 2. Imagine we need to calculate this value several times in our code. It would be useful to have a function that does this for us. Check out how this would look. We use the keyword return to tell Python that this is the return value of a function. When we call the function, we store that value in a variable. Let's say we have the 2 triangles and we want to add up the sum of both areas. Here's what we would do. First, we calculate the 2 areas separately. Then, we add the sum of both areas together. Finally, we print the result, converting it to a string. As you can see in this example, the area triangle function returns a value, which is, not surprisingly, the area of the triangle. We store that value in a different variable for each call to the function. In this case, area A and area B. And then we operate with those values, adding them into the variable called sum, and only printing this final result. This shows the power of the return statement. It allows us to combine calls to functions into more complex operations, which makes your code more reusable. Return statements in Python are even more interesting because we can use them to return more than one value. Let's say you have a duration of time in seconds, and you want to convert that to the equivalent number of hours, minutes, and seconds. Here's how to do that in Python. Did you spot the new operator in this function? That double slash operator is called floor division. A floor division divides a number and takes the integer part of the division as the result. For example, 5//2 is 2 instead of 2.5. In our example, the first operation is calculating how many hours are in a given amount of seconds, while the second works out how many minutes are left once we subtract the hours, and then how many seconds remain after subtracting the minutes. We end up with 3 numbers as a result, so the function returns all 3 of them. Let's see what this looks like when we're calling a function. Because we know that the function returns 3 values, we assign the result of the function to 3 different variables. There's one last thing we should call out about returning values. It is possible to return nothing, and that's perfectly okay. Let's look at an example from an earlier video. Here, the function just printed a message and didn't return anything. What do you think would happen if we try to assign the value of this function to a variable? Let's try it out and see. Here, when we called the function, it printed a message, just like we expected. We stored the return value in the result variable, but there was no return statement in the function, so the value of result is none. None is a very special data type in Python, used to indicate that things are empty, or that they return nothing. Wow, that was a lot to learn about functions and the return values. Remember that the key to getting this right is to practice writing the code you just learned as many times as you need. Functions and return values can be tricky concepts to master, but they let us do a bunch of cool stuff. So put the time and effort in to learn it for some really valuable returns. As we've called out before, functions are powerful because you can create your own. You can use them to organize the code in your scripts into logical blocks, which makes the code you write easier to use and reuse. Check out this example. This script uses the len function, which returns the length of a string. In this example, the script then uses that length to calculate a number, which we're calling the lucky number here. And finally, it prints a message with the name and the number. Each time we want to perform the calculation, we change the values of the variables and write the formula, then print a greeting followed by the lucky number. See how there are exactly 2 lines that are the same in the first and second part of the code? When you find code duplication in your scripts, it's a good idea to check if you can clean things up a bit by using a function. How about we rewrite this code, creating a function to group all the duplicated code into just 1 line? The updated script gives us the exact same result as the original one, but it looks a lot cleaner. First, we've defined a function called luckyNumber, which carries out our calculation and prints it for us. Then we call the function twice, once with each name. Since we've grouped the calculation and print statements into a function, our code is not only easier to read, but it's also now reusable. We can execute the code inside the luckyNumber function as many times as we need it by just calling it with a different name. So we don't have to write it out and again for each new name. Does that make sense? Hopefully these examples have helped explain how functions are used and defined, and also demonstrated how useful they can be. Did you notice that we're feeding information into our functions through their parameters? This is one of the many ways that we can input data into our code. The values for those parameters may come from different places, like a file on our computer or through a form on a website, but that doesn't impact our code. The result of the function is still the same no matter where the parameters come from. Functions are your friends. They can help clean up your code and do math so you don't have to. You'll be using them a lot, both in this course and in your programming life. So get ready to get real friendly with functions. So far, we've looked into how the Python syntax is used for variables, expressions, and defining and using functions. There's a lot more syntax to come, but before we dive into that, let's talk a bit about a different side of programming: style. On the whole, having good or bad style when you write code doesn't make much difference between a script succeeding or crashing, but it can make a big difference for the people who use it and contribute to it. Poor programming style can make life difficult for the IT specialists or system administrators who have to read the script after it's written or make changes to it so it works with a new system. Bad style can even give the script's author a headache if it's been a while since they've wrote it. Imagine having to rewrite your own code because it's too messy to understand. Yikes! On the flip side, good style can make a script look almost like natural human language. It can make the script's intent and construction immediately clear to the reader. Good style makes life easier for people who have to maintain the code and helps them understand what it does and how it does it. It can also reduce errors, since it makes updating the code easier and more straightforward. And most importantly, good style makes you look cool, right? So, we agree, our code should be stylish. But what makes the style of a piece of code good or bad? Although there are no hard and fast rules that apply to every programming language and situation, keeping a few principles in mind will go a long way to creating good, well-styled code. First off, you want your code to be as self-documenting as possible. Self-documenting code is written in a way that's readable and doesn't conceal its intent. This principle can be applied to all aspects of writing code, from picking your variable names to writing clear, concise expressions. Take this code snippet, for example. It's hard to determine the purpose of this code by just looking at it. The names of the variables don't give the reader much information, and although you can likely work out the result of the calculation, there are no clues to what that result might be used for. In programming lingo, when we rewrite code to be more self-documenting, we call this process refactoring. So, how would it look if we refactored this code? With this refactored code, the intent should now be more clear. The names of the variables and the function reflect their purpose, which helps the reader understand the code more quickly. You should always aim for your code to be self-documenting. But even then, sometimes you may need to use a particularly tricky bit of code in your script. When good naming and clean organization can't make the code clear, you can add a bit of explanatory text to the code. You do this by adding what we call a comment. In Python, comments are indicated by the hash character. When your computer sees a hash character, it understands that it should ignore everything that comes after that character on that line. Check out how this looks. Using comments lets you explain why a function does something a certain way. It also allows you to leave notes to your future self or other programmers to remind you of what needs to be improved and why. Obviously, it's much easier to read your own code than someone else's, but in my job, I work on code that was written by lots of different people, and everybody designs things a little differently. This is why it's so important to comment and document your code well. More often than not, your code will eventually be used by someone other than you. So be a good neighbor. Use a style guide to structure your code in a way that's readable by others, or by you in 6 months when you've forgotten why you wrote that code in the first place. In upcoming exercises in this course, we'll use comments to let you know what you need to do with the code, and you can always write as many extra comments as you need. Coming up, a quiz to consolidate your newly acquired knowledge about functions. Don't worry, you've got this. We've seen a few arithmetic expressions so far, like addition, subtraction, and division. Remember when we turned Python into a calculator? Well, Python can also compare values. This lets us check whether something is smaller than, equal to, or bigger than something else. This allows us to take the result of our expressions and use them to make decisions. Check out these 3 examples. In the first example, 10 is greater than 1, so the value true is printed as a result. True is a value that belongs to another data type called a Boolean. Booleans represent one of 2 possible states, either true or false. Every time you compare things in Python, the result is a Boolean of the appropriate value. In the second example, we can see our very first equality operator, which is formed by putting 2 equal signs together. We use this operator to test whether 2 things are equal to each other. In this example, the string cat is not equal to the string dog, so the Boolean that's printed is false. In our third example, we're doing the opposite comparison. By pairing an exclamation mark and an equals sign, we're using the not equals operator, which is the negated form of the equality operator. In this particular line of code, the operator checks that 1 isn't equal to 2. We called out before that the plus operator doesn't work between integers and strings. What do you think will happen if we try to compare an integer and a string? Let's find out by seeing if the number 1 is smaller than the string 1. Womp womp womp. We get a type error. That's the same error we got before. This happens because Python doesn't know how to check if a number is smaller than a string. And what about the equality operator? In this case, the interpreter has no problem telling us that the integer 1 and the string 1 aren't the same. So what gives? Basically, although they may seem similar to us because they both contain the same number, it's clear to the computer that one is a number and the other is a string. For the computer, it's obvious that they are completely different entities. On top of the comparison and equality operators, Python also has a set of logical operators. These operators allow you to connect multiple statements together and perform more complex comparisons. In Python, the logical operators are the words and, or, and not. Let's look at some examples. To evaluate as true, the and operator would need both expressions to be true at the same time. Here we're comparing strings, and the bigger and smaller operators refer to alphabetical order. Yellow comes after cyan, but brown doesn't come after magenta. So this means that the first statement is true, but the second one isn't, which makes the result of the whole expression false. If we use the or operator instead, the expression will be true if either of the expressions are true, and false only when both expressions are false. Let's try it out. 25 is definitely not bigger than 50, but 1 is different than 2. So in the end, the whole expression is true. Last up, the not operator inverts the value of the expression that's in front of it. If the expression is true, it becomes false. If it's false, it becomes true, just like this. Logical operators are important because they help us write more complex expressions. We'll see this in action in the next few videos. If this is the first time you've come across these operators, it might seem like there's a lot to remember. But don't worry, you'll learn most of them very quickly just by practicing. And in the next reading, we have a cheat sheet that lists all the operators available and what each one does. It's a handy resource you're sure to find useful when writing your own scripts. Now that we're armed with knowledge of Python's expressions, comparators, and variables, we can dive right into how to use them in our scripts to perform different actions based on their values. The ability of a program to alter its execution sequence is called branching, and it's a key component in making your scripts useful. You probably use the idea of branching a bunch in your everyday life. For example, if it's before noon, you might greet someone by saying good morning instead of good afternoon or good evening. If it's raining outside, you might choose to take an umbrella. If it's cold, you probably wear a jacket. In your scripts, you can instruct your computer to make decisions based on inputs too. Let's take a look at an IT-focused example. In many companies, new employees can choose the username they'll use to access the company's systems, and usually the chosen username needs to fit with a given set of guidelines. Companies can set different criteria for what a valid username looks like. For now, let's assume that at your company, a valid username has to have at least 3 characters. You've been tasked with writing a program that will tell the user if their choice is valid or not. To do that, you could write a function like this. This function checks whether the length of the username is smaller than 3. If it is, the function prints a message saying that the username is invalid. Look closely at how the if statement is written. We write the keyword if followed by the condition that we want to check for, and then followed by a colon. After that comes the body of the if block, which is indented further to the right. You may notice that there are some similarities between how an if block and a function are defined. The keyword, either def or if, indicates the start of a special block. At the end of the first line, we use a colon, and then the body of the function or the if block is indented to the right. But there's also an important difference between how an if block and a function are defined. The body of the if block will only execute when the condition evaluates to true. Otherwise, it's skipped. Of course, you can do a lot more things inside the body of the if block than just printing stuff. As we expand our programming abilities, we'll learn how to do things like shorten text that's too long, delete a file if it exists, start a service if it's not running, and a bunch more. If your code is inside a function, you could also choose to return a value depending on whether a certain condition is met. Can you imagine how that would look? By now, you know how to define functions, and inside those functions, you can now make your program do something only when certain conditions are met. Ready to branch out and make our branches even more interesting with else statements? Then hop on over to the next video, or else you'll miss out. The if statement is already a pretty useful construct, but we can extend it to make it even more powerful. Think about the username example from the last video. What if we also wanted to print a message when the username was valid? Here, we've included an else statement to achieve this. The program can now go in one of two directions depending on the length of the username. If it's not long enough, we get a message indicating that the username is invalid. But if the program verifies that the username is long enough, it will print a message saying it is valid. Pay attention to how the else statement is written. It uses the else keyword followed by a colon to indicate the beginning of the else block. Once again, the body of the block is further indented to the right. As we've called out before, these blocks can contain multiple lines and do more than just print messages. They can do calculations, modify values, return values, and a lot more. And remember that you can choose to use as many or as few spaces as you want for the indentation. But you always need to indent, and you always need to use the same number of spaces. The else statement is very useful, but we don't always need it. Say we want to have a function that checks if a value is even or odd. We could do that with a piece of code like this. Here we're using a new operator, so let's first explain that. The modulo operator is represented by the percentage sign and returns the remainder of the integer division between two numbers. The integer division is an operation between integers that yields two results, which are both integers, the quotient and the remainder. So if we do an integer division between 5 and 2, the quotient is 2 and the remainder is 1. If we do an integer division between 11 and 3, the quotient is 3 and the remainder is 2. Even numbers are all multiples of 2, which means the remainder of the integer division between an even number and 2 is always going to be 0. In this function, we're using this principle to decide whether a number is even or not. So, how come we have these two return statements, one below the other, without an else statement? The trick is that when a return statement is executed, the function exits, so that the code that follows doesn't get executed. This means that if the number is even, the computer will reach the return true statement and exit the function. Anything that comes after that will only be executed if the condition in the if statement was false. In other words, once the function reaches the return false line, we know for sure that the if condition was false, which means the number was odd. At first, you might feel more comfortable including the else statement even if it's not needed, and that's totally okay. It's important to know that both ways of writing this are correct. And remember that this technique can only be used when you're returning a value inside the if statement. To recap, the if statement allows us to branch the execution based on a specific condition being true. The else statement lets us set a piece of code to run only when the condition of the if statement was false. If you return a value inside an if block, then the code after the block will only be executed if the condition was false. All makes sense? If all these ifs and elses are starting to get a little confusing, that's okay. There's a lot to soak up here, and the best way to do that is, yeah, you guessed it, practice. So review the content and practice on your own as much as you need. Once you're done, meet me over in the next video. The if and else blocks allow us to branch execution depending on whether a condition is true or false. But what if there are more conditions to take into account? This is where the elif statement, which is short for else if, comes into play. But before we jump into how to use it, let's take a look at why we need it in the first place. Let's go back to our trusty username validation example. Now, what if your company also had a rule that usernames longer than 15 characters aren't allowed? How could we let the user know if their chosen username was too long? We could do it like this. In this case, we're adding an extra if block inside the else block. This works, but the way the code is nested makes it kind of hard to read. To avoid unnecessary nesting and make the code clearer, Python gives us the elif keyword, which lets us handle more than 2 comparison cases. Take a look. The elif statement looks very similar to the if statement. It's followed by a condition and a colon, and a block of code indented to the right that forms the body. The condition must be true for the body of the elif block to be executed. The main difference between elif and if statements is we can only write an elif block as a companion to an if block. That's because the condition of the elif statement will only be checked if the condition of the if statement wasn't true. So in this example, the program first checks whether the username is less than 3 characters long and prints a message if that's the case. If the username has at least 3 characters, the program then checks if it's longer than 15 characters. If it is, we get a message to tell us that. Finally, if none of the above conditions were met, the program prints a message indicating that the username is valid. There's no limit to how many conditions we can add, and it's easy to include new ones. For example, say the company decided that the username shouldn't include numbers. We could easily add an extra elif condition to check for this. Cool, right? You now know how to compare things and use those comparisons for your if, elif, and else statements, and you're using all of them inside functions. Using branching to determine your program's flow opens up a whole new realm of possibilities in your scripts. You can use comparisons to pick between executing different pieces of code, which makes your script pretty flexible. Branching also helps you do all kinds of practical things, like only backing up files with a certain extension, or only allowing login access to a server during certain times of the day. Anytime your program needs to make a decision, you can specify its behavior with a branching statement. Are you starting to notice tasks in your day-to-day that could be made more efficient with scripting? There's so many possibilities, and we're only just getting started with all the cool stuff programming can help you do. Wow, we've covered a lot in these last few videos. Remembering all these concepts can take some time, and the best way to learn them is to use them. So we've put together a cheat sheet for you in the next reading. You'll find all these operators and branching blocks listed there in one handy resource. It's super useful when you need a quick refresher. So no skipping the reading. Woohoo! You just completed your second module and learned a whole lot about Python syntax. Congrats! We've learned how to operate with different data types and how to create our own variables and expressions. We've defined our first functions and learned how to make them return values so that they're more reusable. We then dove into creating branches in our scripts, which lets them act in different ways depending on the values of our variables. We've learned a lot of new and very powerful stuff. Knowing how to structure your code and functions and how to make your code act in different ways depending on the values is what allows us to tell our computer what to do. We'll keep using these tools throughout the course as we move on to more complex and interesting things. Next up, you can put everything you've learned to the test in the next graded assessment. Don't worry if you don't feel ready yet. Remember that you can re-watch the videos and do the practice quizzes as many times as you need to make sure you fully understand everything we've covered. When you're ready for the test, take your time, and best of luck. I'll catch you after you've finished in the next module, where we'll learn all about loops. See you there.
My team is responsible for maintaining the operating system of a bunch of computers in the fleet of Google. And many of the things that we do are done through Python scripts. For example, we have a script that keeps the computer up to date, that the software is updated every day, and that's written in Python. We also have a script that checks that the computer doesn't have any specific problems, and if there is a problem, raises an alert for the user so that the user can take action. That one is also written in Python. We have a bunch of other scripts like that run in the computers of our users that are all written in Python. One of the things I like the most about Python is that the code is really readable. You can give a piece of Python code to someone that doesn't even know how to program, and most of the time they will have at least some idea of what's going on. The other thing I like about Python is that it comes with a lot of modules that do a lot of the things that we want to do already. It's been around for a while. There's a lot of people that have contributed all of these modules, so it's very likely that the thing you want to do, it's already in a module and you only have to import it and use it. No computer language is perfect. Every computer language has its advantages and disadvantages. In the case of Python, the one thing that I find the most annoying is that because it's not a compiled language, there could be errors in the code that only get detected very late in the development process. And while it's not good that all these hidden errors could be in the code, it can be mitigated by writing good tests. If you write tests and then the test can test all of the code, even if it's not hit every day, then you can be assured that your code is working successfully. That's why I think Python is great for writing small scripts that are self-contained and not for like big software projects that have a lot of infrastructure on them.
Hi there, and welcome back. Before we dive back in, I want to first say well done. We've learned a lot of new skills in a short amount of time and tackled some pretty tricky concepts. None of this stuff is easy, and you're doing so great. So we've got some fun concepts lined up for the next few videos. So far, we've seen how to organize our code and functions. We've also made our code branch into different paths depending on certain conditions. In this module, we'll learn how to get computers to do repetitive tasks, which is another cornerstone of programming. As we've called out before, computers are great at repeating the same task over and over. They never get bored or make a mistake. You could ask a computer to do the same calculation 1,000 times and the first result would be just as accurate as the last, which isn't something we can say about us humans. Have you ever tried to do something 1,000 times in a row? It'd be enough to drive you loopy. Which is why in this course we're going to learn how to leave the loops up to the computer. The ability to accurately perform repetitive tasks and never get tired is why computers are so great for automation. The automated task could be anything, like copying files to a bunch of computers on a network, sending personalized emails to a list of users, or verifying that a process is still running. It doesn't matter how complex the task is, your computer will do it as many times as you tell it to, which leaves you time for more interesting things, like planning future hardware needs or managing software rollouts. In the next few videos, we'll explore 3 techniques for automating repetitive tasks. These are while loops, for loops, and recursion. Each of these techniques are used to tell the computer to repeat a task, but each takes a slightly different approach. We're going to learn how to write the code for each and how to know when to use one technique instead of the others. So, are you ready? Let's get started. First off, we're going to talk about while loops. While loops instruct your computer to continuously execute your code based on the value of a condition. This works in a similar way to branching if statements. The difference here is that the body of the block can be executed multiple times instead of just once. Check out this program. Can you guess what it does? Before we execute it to find out, let's go through it together line by line. In the first line, we're assigning the value of 0 to the variable x. We call this action initializing, to give an initial value to a variable. In the line after that, we're starting the while loop. We're setting a condition for this loop that x needs to be smaller than 5. Right now, we know that x is 0, since we've just initialized it, so this condition is currently true. On the next 2 lines, we have a block that's indented to the right. Here, we can use what we learned about functions and conditionals to identify that this is the while loop's body. There are 2 lines in the body of the loop. In the first line, we print a message followed by the current value of x. In the second line, we increment the value of x. We do this by adding 1 to its current value and assigning it back to x. So, after the first execution of the body of the loop, x will be 1 instead of 0. Because this is a loop, the computer doesn't just continue executing with the next line in the script. Instead, it loops back around to reevaluate the condition for the while loop. And because 1 here is still smaller than 5, it executes the body of the loop again. It then prints the message and once more increments x by 1. So the x is now 2. The computer will keep doing this until the condition isn't true anymore. In this example, the condition will be false when x is no longer smaller than 5. Once the condition is false, the loop finishes and the next line is executed. And finally, the last line of our code prints the last value of x. So now that this code makes a bit more sense, what do you think will happen when we execute it? Ready to find out? Let's execute the code and see what happens. So we had 5 lines with the message, "Not there yet," and then at the end of the script, the value of x was 5. This was a simple example of how a while loop behaves. As we've said before, we're learning the building blocks of programming. Once you know those building blocks, you can combine them to create more complex expressions. As an IT specialist, while loops can be super helpful. You can use them to keep asking for a username if the one provided isn't valid, or maybe try an operation until it succeeds. Knowing how to construct these expressions can help you get your computer to do a whole lot with only a little bit of code. It's pretty powerful stuff we're learning here. Now that you've got an idea of how a while loop works, let's spice it up with another example. In the last video, we saw a very simple example of a while loop. We looked at a basic syntax of the loop and how it works. Let's now apply this knowledge to a similar example, but this time with a while loop inside a function. Can you work out what this function does? In this example, we start out by initializing a variable called x. In this case, we initialize it with the value of 1. Then we enter our while loop, which checks to see if the value inside of the x variable is less than the parameter n that the function received. If that comparison evaluates to true, then the code inside the while block is executed. Say we pass a value of 5 as a parameter to this function. In the first pass through the loop, x is always equal to 1, so the comparison 1 smaller than or equal to 5 would be true, and we'd then enter the body of the loop. In the body, we first print a message indicating that the current attempt number, and then we increase the value of x by 1. To increment the number, we're using a slightly different expression than before. X plus equal 1 is a shorthand version of x equals x plus 1. You can use either expression since they both mean the same thing. The process continues until the result of the comparison isn't true anymore, which happens when x is bigger than n. In our current example, this would be when the value of x is 6. Let's see it in action. In these past examples, we've used the simple conditions of a number being smaller or equal than another number. These are common conditions, but they're by no means the only conditions you can have in a while loop. It's common, for example, to call a separate function that evaluates the condition, like this. In this case, there's a lot of code hidden behind functions, and it's doing stuff we don't see. There's a getUsername function that asks the user for a username, and a validUsername function that validates that username. And all this is happening in just a handful of characters. As you can see, you can pack a lot of punch into just a short line of code. In this case, the body of the while loop will be executed until the user enters a valid username. The important thing to remember is that the condition used by the while loop needs to evaluate to true or false. It doesn't matter if this is done by using comparison operators or calling additional functions. The conditions used in while loops can also become more complex if we use the logical operators that we encountered when looking into branching, and, or, and not. This lets us combine the values of several expressions to get the result we want. Okay, we've now covered what a while loop is and learned its syntax and basic behavior. Some of this stuff can be a bit tricky, and you're doing great. Keep sticking with it. Next, we're going to do a rundown of some of the most common pitfalls that you may come across when writing your own loops. Head on over to the next video to get started. As we've called out earlier, writing loops allows us to get our computer to do repetitive work for us. Since one of the main benefits of writing scripts in IT is to save time by automating repetitive tasks, loops are super useful. So, let's make sure you avoid some of the most common mistakes people make when writing loops. One of the most common errors is forgetting to initialize variables with the right value. We've all made this mistake when starting to code. Remember how in the earlier examples we initialized our variable x to 0 in one case and to 1 in the other? When we forget to initialize a variable, two different things can happen. The first possible outcome, and the easiest to catch, is that Python might raise an error telling us that we're using a variable we haven't defined. which looks like this. As we've done with other errors we've come across, we can look at the last line to understand what's going on. This error type is a name error, and the message that comes after it says we're using an undefined variable. It's straightforward to fix. We just need to initialize the variable before using it, like this. Fixed. Now, there's a second issue we might face if we forget to initialize variables with the right value. We might have already used the variable in our program. In this case, if we reuse a variable without setting the correct value from the start, it will still have the value from before. This can lead to some pretty unexpected behavior. Check out this script. Can you spot the problem? In the first block, we correctly initialize x to 1 and sum to 0, and then iterate until x equals 10, summing up all the values in between. So by the end of that block, sum equals the result of adding all the numbers from 1 to 10, and x is 10. In the second part of the code, the original intention was to get the product of all the numbers from 1 to 10. But if you look closely, you can see that we're initializing product, but forgetting to initialize x. So x is still 10. This means that when the while condition gets checked, x is already 10 at the start of the iteration. The while condition is false before it even starts, and the body never executes. Let's see how this problem would look. In this case, it might be harder to catch the problem because Python doesn't raise an error. The problem here is that our product variable has the wrong value. If you have a loop that's gone rogue and not behaving as expected, it's a good idea to check if all the variables are correctly initialized. In this example, we need to set x back to 1 before starting the second loop. As always, the best way to learn is to practice it yourself. Make sense? Remember, if you ever feel stuck or a little unsure about something, you can always ask for help in the discussion forums. These forums are there to let you get the help you need when you need it. So don't forget to use them. So, to recap, whenever you're writing a loop, check that you're initializing all the variables you want to use before you use them. And don't worry if you don't get it right the first time. We've all been there when learning how to code. As we've called out before, the way to master programming is to practice, practice, practice. Keep practicing until you're comfortable. And even then, it's still okay to make mistakes. So don't feel like you can't, loop back around to review and practice everything we've covered so far. You may remember by now that while loops use a condition to check when to exit. The body of the while loop needs to make sure that the condition being checked will change. If it doesn't change, the loop may never finish, and we get what's called an infinite loop, a loop that keeps executing and never stops. Check out this example. It uses the modulo operator that we saw a while back. This cycle will finish for positive and negative values of x. But what would happen if x was 0? The remainder of 0 divided by 2 is 0, so the condition would be true. And the result of dividing 0 by 2 would also be 0, so the value of x wouldn't change. This loop would go on forever, and so we'd get an infinite loop. If our code was called with x having the value of 0, the computer would just waste resources doing a division that would never lead to the loop stopping. The program would be stuck in an infinite loop, circling back around endlessly. And we don't want that. All that looping might make your computer dizzy. To avoid this, we need to think about what needs to happen for a loop to be successful. In this example, we said that x needs to be different than 0. So we could nest this while loop inside an if statement, just like this. With this approach, the while loop is executed only when x is not 0. Alternatively, we could add the condition directly to the loop using a logical operator, like in this example. This makes sure we only enter the body of the loop for values of x that are both different than 0 and even. Talking about infinite loop reminds me of one of the first times I used while loops myself. I wrote a script that emailed me as a way of verifying that the code worked. And while some condition was true, I forgot to exit the loop. Turns out those emails get sent faster than once per second. As you can imagine, I got about 500 emails before I realized what was going on. Infinitely grateful for that little lesson. When you're done laughing at my story, remember, when you're writing loops, it's a good idea to take a moment to consider the different values a variable can take. This helps you make sure your loop won't get stuck. If you see that your program is running forever without finishing, have a second look at your loops to check there's no infinite loop hiding somewhere in the code. While you need to watch out for infinite loops, they're not always a bad thing. Sometimes you actually want your program to execute continuously until some external condition is met. If you've used the ping utility on Linux or macOS system, or ping-t on a Windows system, you've seen an infinite loop in action. This tool will keep sending packets and printing the results to the terminal unless you send it the interrupt signal, usually pressing Ctrl-C. If you were looking at the program's source code, you'd see that it uses an infinite loop to do this, with a block of code with instructions to keep sending the packets forever. One thing to call out is it should always be possible to break the loop by sending a certain signal. In the ping example, that signal is the user pressing Ctrl-C. In other cases, it could be that the user pressed a button on a graphical application, or that another program sent a specific signal, or even that a time limit was reached. In your code, you could have an infinite loop that looks something like this. In Python, we use the break keyword, which you can see here, to signal that the current loop should stop running. We can use it not only to stop infinite loops, but also to stop a loop early if the code has already achieved what's needed. So, quick refresh. How do you avoid the most common pitfalls when writing while loops? First, remember to initialize your variables, and second, check that your loops won't run forever. Wow, all this talk of loops is making me feel a little loopy. I'm gonna have to go and lie down while you do the next practice quiz. Best of luck, and meet me over in the next video when you're done. Okay, how are you doing? If all this talk of loops is starting to make your head spin, remember that there's nothing wrong with looping back around and reviewing what you've learned. It's the quickest way to stop feeling like you're running in circles. All right, feeling good? Great, then we're ready for a different type of loop. In this video, we're going to meet the for loop. A for loop iterates over a sequence of values. A very simple example of a for loop is to iterate over a sequence of numbers, like this. Notice how this structure is kind of similar to the structures we've already seen. The first line indicates the distinguishing keyword. In this case, that's for, and it ends with a colon. The body of the loop is indented to the right, like we saw in the while loop, the if block, and the function definitions. What's different in this case is that we have the keyword in. Also, between the for keyword and in keyword, we have the name of a variable. This variable will take each of the values in the sequence that loop iterates through. So in this example, it'll iterate through a sequence of numbers generated using the range function. There are two important things I want to call out about this range function. First, in Python and a lot of other programming languages, a range of numbers will start with the value 0 by default. Second, the list of numbers generated will be one less than the given value. In the simple example here, x will take the values 0, 1, 2, 3, and 4. Let's check this out. So there we have a very basic for loop. It iterates over a sequence of numbers generated by the range function. When using a for loop, we point the variable defined between for and in this case x, at each element of the sequence. This means on the first iteration, x points at 1, on the second iteration it points at 2, and so on. Whatever code we put in the body of the loop will be executed on each of the values, one value at a time. As we said earlier, the loop's body can do a lot of things with the values it iterates. For example, you could have a function to calculate the square of a number, and then use a for loop to sum the squares of the numbers in a range. Iterating over numbers looks very similar to the while loop examples we showed before. So you may be wondering, why have two loops that look like they do the same thing? Well, the power of the for loop is that we can use it to iterate over a sequence of values of any type, not just a range of numbers. Think all the way back to our very first Python example in this course. Remember our trusty Hi Friends script? In it, we saw a for loop that iterated over a list of strings. It looked like this. We'll talk a lot more about lists later on, but for now, you only need to know that we can construct lists using square brackets and separate the elements in them with commas. In this example, we're iterating a list of strings, and for each of the strings in the list, we're printing a greeting. The sequence that the for loop iterates over could contain any type of element, not just strings. For example, we could iterate over a list of numbers to calculate the total sum and average. Here's one way of doing this. Here, we're defining a list of values. After that, we're initializing two variables, sum and length, that will update in the body of the for loop. In the for loop, we're iterating over each of the values in the list, adding the current value to the sum of values, and then also adding 1 to length, which calculates how many elements there are in the list. Once we've gone through the whole list, we print out the sum and the average. We'll keep using for loops in our examples every time we want to iterate over the elements of any sequence and operate with them. Some examples of sequences that we can iterate are the files in a directory, the lines in a file, the processes running on a machine, and there's a bunch of others. So as an IT specialist, you'll use for loops to automate tons of stuff. For example, you might use them to copy files to machines, process the contents of files, automatically install software, and a lot more. A few weeks ago, I had to update a lot of files with different values depending on their contents. So I used a for loop in a script to iterate over all the files. Then my script took different actions based on an if condition and updated all of those files for me. It would have taken me forever if I had done this manually file by file. If you're wondering when you should use for loops and when you should use while loops, there's a way to tell. Use for loops when there's a sequence of elements that you want to iterate. Use while loops when you want to repeat an action until a condition changes. And if whatever you're trying to do can be done with either for or while loops, just use whichever one's your favorite. I'm more of a while gal myself, but it's totally your call. Next up, we've put together more examples to help get you more practice with for loops and discover some of the cool things you could do with them. In the last video, we talked about the range function and how it generates a sequence of numbers starting with 0. Sometimes, though, we don't want to start with 0. For these situations, the range function also allows us to specify the first element of the list to generate. We do that by passing 2 parameters to the function instead of 1, like in the next example. Product equals 1 for n in range 1 to 10. Product equals product n print product. In this example, we're calculating the product of all numbers from 1 to 10. For this operation, it's important that we start with 1 and not with 0. If we'd started with 0, the whole product would be 0. Additionally, we can specify a third parameter to change the size of each step. This means that instead of going 1 by 1, we could have a larger difference between the elements. Let's check out this example of when you might want to do something like this. First, we're defining a function that converts a temperature value from Fahrenheit to Celsius. And we're simply using a conversion formula to do that. Then, we have a for loop that starts at 0 and goes up to 100 in steps of 10. Notice that we're using 101 for the upper limit instead of 100. We're doing this because the range never includes the last element, and we want to include 100 in our range. The body of the for loop prints the value in Fahrenheit and the value in Celsius, creating a conversion table. Let's see this in action. That example got you feeling the heat? Don't worry, there's a quick rundown of what we've learned. The range function can receive 1, 2, or 3 parameters. If it receives 1 parameter, it will create a sequence, 1 by 1, from 0 until 1 less than the parameter received. If it receives 2 parameters, it will create a sequence, 1 by 1, from the first parameter until 1 less than the second parameter. Finally, if it receives 3 parameters, it will create a sequence starting from the first number and moving towards the second number, but this time the jumps between the numbers will be the size of the third number. And again, it will stop before the second number. This might sound like a lot to remember, but don't panic. As we've said before, you don't have to try to memorize it all, just keep practicing, it'll soon become second nature. And to help you practice, we've included all of this in a handy cheat sheet to refer to whenever you need it. You'll find that in the next reading. You're doing great getting your head around all these loops. I think you're ready for something a little bit more complex. We're going to explore what happens when you get loops inside of loops. Does that make your head spin? Don't worry, we're about to break it down for you with a couple of examples. Have you ever played dominoes before? There's a bunch of fun games you can play with these tiles. In case you're not familiar, each domino tile has two numbers represented by a collection of dots carved on each half of the tile. The numbers go from 0 to 6. Tiles can be rotated so that each combination of numbers is represented only once in a set of domino tiles. In other words, the 2-3 tile is the same as the 3-2 tile, and there's only one per set. Now, imagine we wanted to write a program that prints each domino tile in a set. If we take all of the tiles that have 0 on the left, we can print tiles with numbers from 0 to 6 on the right. That should be easy to do with a for loop. But what about tiles that have 1 on the left? Well, we need to skip the 1-0 tile because that one was already printed as 0-1. So, we could print a list of tiles with 1 on the left and numbers from 1 to 6 on the right. When we look at 2, we would need to skip both 0 and 1, and so on. Are you following along? How do you think we'd write the code for this? Turning this into code means that we'd need to write 2 for loops, one inside the other. This is what we call nested for loops. Check out how this looks in Python code. For left in range 7, for right in range left 7, print, we're going to do left bracket plus str left plus pipe plus str right plus close bracket end equals space. And print. In this code, we're using a new parameter that we pass to the print function. This parameter is called end. Normally, once print has taken the content we passed and written it to the screen, then it writes a special character that creates a new line called the new line character. If we want print to write something else instead of the new line character, we use the end parameter, like we see in this example. Notice how the second for loop iterates over a different number of elements each time it's called as the value of left changes. Depending on what you want to achieve with your nested loops, you may want both loops to always go through the same number of elements. Or you might want the second loop to connect to the first one. Let's look at a different example. Let's say you run a local girls' basketball league in your town. You have 4 teams that will play against each other in the league, both at home and away. You've stored the names of the teams in a list, like this. We want to write a script that will output all possible team pairings. For this, the order of the names matters because for each game, the first name will be the home team and the second name is the away team. And of course, what we don't want to do is have a team playing against itself. So, what statement do we need to use to avoid that? To do this, we need to use a conditional that makes sure we only print the pairing when the names are different. Check out what this looks like. For home team in teams, for away team in teams, if home team not equal to away team, print home team versus away team. Success! As you can see, nested loops are super useful for solving certain problems, like pairing teams. What it doesn't solve is the question, who would win in a face-off between dragons and unicorns? If only there were some code for that. Anyway, we've seen that nested loops are a handy tool, but we need to be careful not to just blindly apply them to any problem. Why? Well, because the longer the lists your code needs to iterate through, the longer it takes your computer to complete the task. Let's say your manager asks you to do an operation that will run through a list of 10,000 elements. If the operation takes 1 millisecond per element, the whole loop would take 1 millisecond times 10,000 to complete, which is 10 seconds. Now, imagine we add a nested loop that has to go over the same 10,000 elements. This means that each iteration of the outside loop would do a full iteration of the inside loop, which again would take 10 seconds to go through the whole list. So now the whole iteration takes 10,000 times 10 seconds, which is 100,000 seconds. That's over 27 hours. I have the patience of a gnat, so that would definitely not work for me. This doesn't mean we shouldn't use nested loops. They're a useful tool when solving problems that require them, but we need to be careful of where and how we use them. Throughout this course, and ones coming up, we'll look at a lot of techniques that can help us pick the right tool to use for each type of problem. Up next, we'll look into some common errors that you might come across when writing your for loops and what to do about them. We've now seen how to write for loops, combine them with functions, nest a for loop inside a different loop, and even combine a nested loop with conditionals. Nice job, you're chugging right along. But before we're done with for loops, let's check out some common mistakes you may come across while trying this yourself. As we've called out already, for loops iterate over sequences. The interpreter will refuse to iterate over a single element. As you see here, for x in 25, print x. In this example, we're trying to iterate over the number 25. Python prints a type error telling us that integers are not iterable. There are two solutions to this problem, depending on what we're trying to do. If we want to go from 0 to 25, then we use the range function. So for x in range 25, print x. But if we're trying to iterate over a list that has 25 as the only element, then it needs to be a list. And that means writing it between square brackets. For x in list 25, print x. You might be wondering why you'd ever want to iterate over a list of one element. And that's a good question. Well, this kind of issue usually happens when you have a function with a for loop inside it, which is iterating over the elements of a list received by parameter. Say, for example, you have a function that fixes the permissions of a list of files received by parameter, and you want to call this function to fix the permissions of just one specific file. To do that, you need to pass the file as the single element of a list. Let's check this out with some code we're familiar with, our friendliest of Python examples. Hi, friends. We're going to modify it to have the greetings inside a function. We've defined a greetFriends function that receives a list by parameter and iterates over that list, greeting each friend. But what if we only want to greet one friend instead of 4? Well, we still need to define a list, but with only one element. But first, let's see what would happen if we don't do that. GreetFriends Barry. Huh, not what we expected, right? Well, what's going on here? This happens because strings are iterable. The for loop will go over each letter of the string and do the operation we asked it to do, which in this case, print a greeting. Depending on what you're trying to do, you may actually want to iterate through the letters of a string, but in this case we don't. So, to sum it up, if you get an error that a certain type isn't iterable, you need to make sure the for loop is using a sequence of elements and not just one. And if you find your code iterating through each letter of a string when you want it to do it for the whole string, you probably want to have that string be a part of a list. We've now learned how to write while loops and for loops. You might remember, for loops are best when you want to iterate over a known sequence of elements, but when you want to operate while a certain condition is true, while loops are the best choice. Next up, we've got a super useful cheat sheet for you that puts all this into one handy resource. After that, head over to the practice quiz to test your knowledge and check in on how you're doing. Welcome back. How are you feeling after the last quiz? We're starting to learn some pretty cool things that we could do in our code, right? And who knew loops could be so fascinating? We've now discovered two looping techniques that we could use in Python, while loops and for loops. We use while loops when we want to do an operation repeatedly while a certain condition is true. And we use for loops when we want to iterate over the elements of a sequence. Now, we're going to check out a third technique called recursion. But before we dive in, you may have noticed that this video is marked as optional. That's because while recursion is a very common technique used in software engineering, it's not used that much in automation. Still, we think it's valuable for you to know about recursion and to have an idea of how to use it. You may see it in code written by others, or you may face a problem where recursion is the best way to solve it. So while the next few videos are marked as optional and you won't be graded on their content, it's still super valuable stuff. Of course, feel free to skip them if you'd just rather focus on concepts you'll be graded on. Let's dive in. Recursion is the repeated application of the same procedure to a smaller problem. Have you ever played with a Russian nesting doll? They're a great visual example of recursion. Each doll has a smaller doll inside it. When you open up the doll to find the smaller one inside, you keep going until you reach the smallest doll, which can't be opened. Recursion lets us tackle complex problems by reducing the problem to a simpler one. Take our Russian nesting dolls, all nested inside each other, and imagine we want to find out how many dolls there are in total. We would need to open each doll one by one until we got to the last one, and then count how many dolls we've opened. That's recursion in action. Here's another example with a more complex problem. Imagine you're in a line of people and you want to know how many people are in front of you. And let me tell you, I can't stand long lines. Anyway, if the line's long, it might be hard to count the people without leaving the line and losing your place. So instead, you could ask the person in front of you how many people are in front of them. Since this person will be in the same situation as you, they'll have to ask the same question to the person in front of them, and so on until the question reaches the first person in the line. This person can confidently reply that there are no people in front of them. So then, the second person in line can reply 1, the person behind them replies 2, and so on until the answer reaches you. Okay, I know the chances are pretty small that all those people would play along just so you can know where you are in line, but it's a useful way to visualize how recursion works. How does this translate into programming? Well, in programming, recursion is a way of doing a repetitive task by having a function call itself. A recursive function calls itself, usually with a modified parameter, until it reaches a specific condition. This condition is called the base case. In our earlier examples, the base case would be the smallest Russian doll, or the person at the front of the queue. Let's check out an example recursive function to understand what we're talking about. Here, we're defining a function called factorial. At the beginning of the function, we have a conditional block defining the base case, where n is smaller than 2. It simply returns the value 1. After the base case, we have a line where the factorial function is calling itself with n minus 1. This is called the recursive case. And this creates a loop. Each time the function is executed, it calls itself with a smaller number until it reaches the base case. Once it reaches the base case, it returns the value 1, and then the previously called function multiplies that by 2, and the previously called function multiplies it by 3, and so on. This loop will keep going until the first factorial function called returns the desired result. It's a bit complex, right? Let's add a few print statements to see exactly how this works. So here we can see the function kept calling itself until it reached the base case. After that, each function returned the value of the previous function multiplied by n until the original function returned. Cool, huh? Next up, we're going to check out some more examples of when to use recursion and when it's best to avoid it. By now, you've seen what a recursive function looks like, how to write a base case and a recursive case. You might be wondering, why do we need recursive functions if I can just use a for or while loop? Well, solutions to some specific problems are easier to write and understand when using recursive functions. A lot of math functions like the factorial or the sum of all the previous numbers are good examples of this. If a math function is already defined in recursive terms, it's straightforward to just write the code as a recursive function. But it's not just about math functions. Let's check out a couple of examples of how this could help an IT specialist trying to automate tasks. Let's say that you need to write a tool that goes through a bunch of directories in your computer and calculates how many files are contained in each. When listing the files inside a directory, you might find subdirectories inside them, and you'd want to count the files in those subdirectories as well. This is a great time to use recursion. The base case would be a directory with no subdirectories. For this case, the function would just return the amount of files. The recursive case would be calling the recursive function for each of the contained subdirectories. The return value of a given function call would be the sum of all the files in that directory plus all the files in the contained subdirectories. A directory of files that can contain other directories is an example of a recursive structure, because directories can contain subdirectories that contain subdirectories that contain subdirectories, and so on. When operating over a recursive structure, it's usually easier to use recursive functions than for or while loops. Another IT-focused example of a recursive structure is anything that deals with groups of users that can contain other groups. We see this situation a lot when using administrative tools like Active Directory or LDAP. Say your group management software allows you to create groups that have both users and other groups as their members, and you want to list all human users that are part of a given group. Here, you would use a recursive function to go through the groups. The base case would be a group that only includes users, listing all of them. The recursive case would mean going through all the groups contained, listing all the users in them, and then listing any users contained in the current group. It's important to call out that in some languages there's a maximum amount of recursive calls you can use. In Python, by default, you can call a recursive function 1,000 times until you reach the limit. That's fine for things like subdirectories or user groups that aren't thousands of levels deep, but it might not be enough for mathematical functions like the ones we saw in the last video. Let's go back to our factorial example from the last video and try to call it with n equals 1,000. Factorial 1,000. See that error? It's telling us that we've reached the maximum limit for recursive calls. So while you can use recursion in a bunch of different scenarios, we only recommend using it when you need to go through a recursive structure that won't reach 1,000 nested levels. All right, we've just added recursion to your growing scripting toolbox. They're ready for you whenever the situation calls for it. Wow, we've come a long way and you've learned a lot already. Now's a good time to stop and give yourself a big pat on the back. In this module, we've looked at ways we can use to tell a computer to do an action repetitively. Python gives us 3 different ways to perform repetitive tasks: while loops, for loops, and recursion. We use while loops when we want to do an operation while a certain condition is true, or alternatively until it becomes false. We use for loops when we want to iterate over the elements of a sequence or a range of numbers. And we use recursion when the problem is best solved in smaller steps and then combining those steps towards a larger solution. If you're still not sure which is the best tool to choose for a specific problem, don't worry, that's normal.